Okay, everyone, so in this example we have a 0.55 kilogram mass that's attached to a spring on a horizontal frictionless surface, and the spring constant is 485 newtons per meter. The spring is going to be stretched an initial amount and released, and we want to determine the velocity of the mass as it reaches these different points, as it gets closer and closer to the equilibrium point. And then for the last part, again, we're going to find the total energy of the system. And so here we have a mass attached to a spring on a frictionless surface. In this particular problem, there will be no gravitational potential energy. So the initial and final energies are just the spring potential energy and the kinetic energy. And again, we know that it's stretched to 0.25 meters before it's released. And so initially, it's not moving, and so it does not have any initial kinetic energy. It has only spring potential energy initially. And so here we know the spring constant, we know the initial and final x position, and we know the mass of the block. We need only find the final velocity. And so here we find the final velocity to be 4.45 meters per second. For part B and part C, the equation is exactly the same. We're simply going to replace the 0.2 with 0.14 or 0.05 and then solve the problem again. And so if we replace 0.2 with 0.14, we find the final velocity is 6.15 meters per second. And then again for part C, we're just going to repeat the same thing, except now instead of 0.14, we're just going to replace it with 0.05. And if we replace for part C, we find that the final velocity is 7.27 meters per second. And so finally for part D, again, we need only use the initial potential energy to find the total energy of the system.